All right, 5.1, proving identities. Take a moment to pause this and write these down. These top 6 fall under your reciprocal identities. The ones down below here fall under your ratio identities, okay? Keep in mind, hopefully remember that sine and cosecant are reciprocals of each other. Cosine and secant are reciprocals, and cotangent and tangent are reciprocals of each other. So go ahead, pause, and jot these down. All right, and here are your Pythagorean identities. Go ahead, once again, pause this, jot these down, and then we'll start proving identities right after you jot these down, right? All right, here's the first identity we're going to prove. Now, all the examples I'm giving you, I haven't worked out on my own first, okay? Because I want you to kind of hear me talk through the process of what I'm thinking and going through this to help you in your planning. So I see secant theta times cotangent theta is equal to cosecant theta. One strategy for these that I like to use is if I can make these into this left side into a sine and cosine problem, it might help me. Meaning, use my identities that can change secant and cotangent into sine and cosine. 1 over cosine is equal to secant, and then cotangent's cosine theta over sine theta. And what do we notice? I see cosine over cosine, that cancels. I'm left with 1 over sine theta. What do we know about 1 over sine theta? It's equal to cosecant theta. And there we go. We did it. We proved our first one together. All right, example 2. So, this is an interesting one. What I'm going to start with, I think I want to distribute the sine x. Now, some of you might pick up on one thing real quick, and that is we have sine x times cosecant x, and we know they're reciprocals of each other. When we multiply reciprocals of each other, we get 1. And let's change secant x to its reciprocal. So we cosine 1 over cosine x. And sine times 1 over cosine is going to be sine x over cosine x. And sine over cosine, as we all know, is tangent. So we did it. We got to tan x plus 1 equals tan x plus 1. All right, next one. Ooh, we got a doozy here. So what I'm going to do is I think I'm going to factor the numerator here. So when we do that, it's just a sum of squares problem. So we get sine squared t plus cosine squared t times sine squared t minus cosine squared t. I might run out of space here. I know because of my Pythagorean identities this is 1. So I'm just left, 1 times anything is itself, so I'm just going to be left with this right here. And now, so be careful with, basic properties. I cannot just go cancel the signs, cancel cosines because of a subtraction sign. But what I can do is divide each of them individually. There we go. And then the sine, I noticed right away, sine t's do cancel. Now I can cancel those out. And I'm left with 1 over cosine squared t minus 1 over sine squared t. And then 1 over cosine secant squared t. And And 1 over sine squared t is cosecant. And we did it. They match up against each other. All right, next identity. Who is the doozy here? There's a couple different ways I can see this one, depending on if I want to work from the right or to the left. What I might do is, in order to get a common denominator and go from there, so I might just multiply this right here by 1 plus sine, not plus plus, oops. 1 plus sine theta over 1 plus sine theta. If I follow the numerator, I'm going to get 1 minus sine squared theta over 1 plus sine theta. And if you can recall, we know that 1 minus sine squared theta is actually equal to cosine squared theta. I know it doesn't tell you in your Pythagorean identity exactly, but if you remember, sine squared theta plus cosine squared theta is equal to 1. Subtract sine squared theta. And look, 1 minus sine squared theta is equal to cosine squared theta. Boom, did it. Hooray. So cosine squared theta over 1 plus sine squared theta, not squared theta, just sine theta, is equal to itself. And last one together. This is going to be a doozy. Our c cosecant, once again, as I said before, let's change it in terms of sine. That might give us a little bit of a hand. Oh, it's going to give us a lot of a hand. How about this? Like this one. So then I'm going to be like, okay, let's multiply the top and the bottom by sine over sine, because we can do that. It's like multiply by 1. The sine divided by sine is 1. So sine x over sine x, that's going to get me this, sine x over sine x minus sine x. Oop, I forgot to multiply by sine. And that's going to give us 1. Oh, look at that. We did it. Because sine x divided by sine x is 1. And we did it. And that's everything. I appreciate you watching, and we'll see you in class.